Right, here we go again. This is one of the topics. This is one of the great integration topics. Integration by substitution. The next one being integration by parts. Those are the two big things here. So integration by substitution is one of those things where it can be quite tricky depending on the question, all right? So basically, you got something like this, integral of x root 2x plus 5 dx. Now, integrating that can be a bit of a pain, but it can be simplified a lot by doing a change of variable. So you can just do a variable change, integrate that, and then undo the variable change. That's basically the idea behind this. Typically, or more often than not, you'll be told what substitution to use, but sometimes you won't. And then it's up to you to figure out an obvious variable change and take it from there, okay? So here, I want to integrate x root 2x plus 5 dx, and they tell me to use the variable substitution u equals 2x plus 5. Okay, so they tell me to use that. So inside the square root, I'm going to write u, but then from here, I also need to get that x equals u minus 5 over 2. And now I can rewrite my integral with these two things as the integral x is u minus 5 over 2 times square root of u dx, though, relative to x. But I haven't got an x anymore, I've got a u. So I need to integrate relative to u. So I need to swap that dx for a du. And I cannot just rewrite it. If you look here on the variable change that they've told us to do, if I differentiate that, du over dx is 2, which means that if I rearrange, dx is du over 2, is it not? So I need to substitute this for this. So my integral ends up being u minus 5 over 2 times root u, and instead of dx, I'm going to write du over 2. Now I can integrate this. So what I'm going to do is that 2 and the 2 are multiplying together, bring it out of the integral sign because it is a constant. So what I've got is 1/4 the integral of u to the 3/2 minus 5u to the 1/2 du. What I've done is multiply the u by the root u and then minus 5 times the root u and write it in index form. And now if I integrate this, I get 1/4, which multiplies u to the 5/2 2 over 5, because I've got u, so I need to adjust the coefficient, minus u to the 3/2, and that's going to be 10 over 3, I believe. And that should be correct. And now we can simplify. That's going to be u to the 5/2 over 10 minus 5 over 6 u to the 3/2 plus c. We haven't quite finished though, because this is all in terms of u and we were integrating relative to x. So now I need to undo the variable change. So I need to substitute u for its equivalent expression. So my final answer is going to be 2x plus 5 to the 5 halves over 10 minus 5 times 2x plus 5 to the 3 halves over 6 plus c. And this is one of the easier examples that you could get, and we're going to do a trickier one next. Okay, so here we go. Example number 2 looks like an absolute mess. Integrate cos x sin x 1 plus sin x cubed dx. They tell me to use that u equals sin x plus 1. The first thing probably we should be doing here is to find the u over dx is going to be cos x. And if I rearrange that, the u equals cos x dx. So now that cos x with that dx is going to be my du, so that's taken care of. And now I only need to substitute in there. So this, if I rewrite it in terms of u, is just going to be sin x is going to be u minus 1 times 1 plus sin x is u cubed, and we said that cos x dx is just du, which means that this is the integral of u to the 4 minus u cubed du. And this is a lot easier to integrate than the mess we had at the beginning. So if we just integrate that, we get u to the 5 over 5 minus u to the 4 over 4 plus c, indefinite integral. I haven't finished because everything is in terms of u, and I have to undo my variable change. U is sin x plus 1, so all I'm going to do is write that equals sin x plus 1 to the 5 over 5 minus sin x plus 1 to the 4 over 4 plus c, and we are done. Typically, hopefully, they will give you the substitution variable to make. Which one to use comes with practice, and typically, whenever you see a square root, whatever's inside the square root is going to be the thing that you're going to substitute, or you could maybe substitute the whole square root and just work in powers of that, but you know, this is the idea. Again, not too complicated, practice makes perfection. You'll be fine, I believe in you. Let me know if you've got any problems.